Alright, now number 63 is a very tough problem, and if you're watching this, I'm pretty sure I know why. There's either one or two ways. Number one, you didn't convert centimeters into meters, and number two, you really don't know how to handle the 33 1/3 revolutions per minute. So, what we'll do, we'll start with a picture. Here's a record, and this record player is revolving at 33 1/3 RPM. So every minute it makes 33 1/3 revolutions. So, and there's a coin on this that goes around the record player as it spins. Now, part A says, well, what direction is the acceleration? Now, the acceleration is always towards the center. Part B wants to know what is the centripetal acceleration when the radius is 5 centimeters, so that's 0.05 meters. When it's 5 centimeters, 10, and 15. So here's what to find the centripetal acceleration, it's velocity squared over the radius. Now, finding the velocity is the hard part because we already know the radius. The radius of this is 0.05. So figuring out the velocity is the tricky part. Now remember, velocity is distance divided by time. Now this thing, this coin, goes around this thing 33.3 times in 1 minute. So it keeps circling and circling, and in 1 minute it goes around the horn 33.3 times. Now, so the distance is 33 times around the circle. And the time is 1 minute. So believe it or not, this is kind of the speed in a way. So to find the distance, it's 33.3 times the circumference. 2 pi r, 0.05. And the time is 60 seconds. Because you want this in meters per second. So that's why we want to get rid of the minutes. You don't need to do minutes. Or you don't need to do seconds, but you got to make sure that when you solve this that you write the appropriate units on the end. So this entire quantity is my velocity, right? So I take 33.3 times 2 times pi times this divided by 60, put it in there, and then I square it and divide it by 0.05, and that gives me my centripetal acceleration for it, and that comes out to be 0.61 meters per second squared. Now the only way this is different, how this is different so when the coin moves out to 10 is we change this. This no longer is 0.05, it's 0.10. And same with over here, you change this to 0.10. So you're just going to go through that and just redo those two numbers, and you end up, and it's really funny because it equals 1.22 meters per second squared. And then when you put in 0.15, it's 1.83 meters per second squared. Like that. Part C asks, what force is doing this? Friction turns it. Friction is what's turning this coin. You know, and if this was a really slippery record, friction wouldn't be able to hold it in the circle. You know, if this was an ice record, no problem. It would just fling off. And part D says which of the 3 radii would be most likely for it to fall off? Well, the farthest one away, 15 centimeters. And then why? When it's the farther away it is, the faster it's going. So the faster it's going, it takes more force to keep it in that circle. So it's moving faster. And needs more force to turn it.